Switch on the mic at all. So, suppose this question is there, no. This is definitely. See, for example, this question, if it is asked in MCQ, right? You need not do all these steps. You can just give me the hint saying that square root of p is a prime, square root of prime number is irrational plus another irrational. That is why the answer is irrational. You're choosing that option. That is enough. I don't want you to sit and prove because you're already doing this in your CBSE. But okay. Whereas if some questions you're doing some calculation part or something, right? If you're doing some calculation, sometimes if you're trying to use the options to find out which one is right, you're trying to follow the elimination method, show that elimination method also. Whatever logic you are using to solve the problem, show it to me. That is what I'm asking. It is only to analyze how much you have understood. Okay, so that is important. And at the end of every question, see, for example, you're solving third question, you will write down the steps. At the end, write down whichever option is correct. Option A, like this. They'll give you papers. They'll give you papers. Okay, hard copy is already given. The question papers are already given. So you will get the question papers. You need to write it on the Sankkn Academy sheet that they will give you and then submit it to us. Okay. No. Only for assignment you will do that. Okay. So next chapter is polynomials. This is over, right? Polynomials. So they have taught you real numbers, polynomials, linear equations and two variables, quadratic equations, and probabilities. So triangles they have started, probability is over, right? Okay. Then we'll start with polynomials. This is a very, very easy chapter. Right? Easy, no? So what is polynomial basically? So polynomial leads you to something. Like this will give you a lead to some other chapter that you have already studied. The fourth chapter, that is the quadratic equations, right? So what do you basically mean by a polynomial? Yeah, you can give your own expression. So how do you write it generally? If I ask you to give me an example of polynomial, will you be able to give? You have it on the board itself. 3x plus. Want to take 3x plus 0 or anything else? 4x square plus 2x plus 5. Whatever number comes to your mouth. 3x cube plus 6x plus 5 plus 1. Oh, sorry, 3x cube plus 6x square plus 5x plus 1. Can we take it like that? So these are all called polynomials, right? So you have a name associated with it. Generally, how do you represent a polynomial? You use the symbol P, and you put something like this. P of x is equal to, and you'll write an expression, right? See, for example, I write an expression 2x square plus 3x plus 1. I call this as a polynomial, right? If I have to speak about this in a more matured way, right? This is called as a polynomial function. Has anyone heard of the word called function? Yes. Polynomial, you call it as polynomial function. Basically, functions, it is represented like this, f of x. F of x is equal to, if I have some expression in terms of x square plus 2x plus 1, if I have something like this, right, then I can call this as a function. And more specifically, this type of a function is called as polynomial function. Are you able to understand what I'm saying? For example, if I give you f of x is equal to 1, what did I write? Left hand side I told you f of x, and right side I told you it is 1. What is 1 basically? It is a, see, for example, if I take this x square plus 2x plus 1, 1 is a constant, right? So if I write f of x is equal to 1, that is also called as a function. The prefix that you will add to that function is constant function. See, about the functions you will learn more in your 11th standard. Okay, are you able to understand what I'm trying to say? Similarly, if I want to write f of x is equal to sin x, for example, you know what is sin? You have heard of this? You will be learning about this. In trigonometry, you will be learning opposite by hypotenuse. All those things we'll learn. Okay. But if I write something like this, this is also called as a function. And what will be the prefix that you will add? Trigonometric function. Okay. Out of which one of the contexts that we are going to read in this chapter is called as a polynomial function. In your 10th standard, we don't use the word called as function. We generally call it as polynomials. Okay. But let's try to understand how exactly functions work, because we are learning about the same thing. In polynomials. Okay. So if you observe, when I write p of x, I have an expression on the right hand side. When I say an expression, it has certain terms associated with it. Can I say? So when you look at those terms are combinations of what? So you have combination of constants, that is a fixed number, and you have variables. Am I right? So what do you mean by that variable? Why do you call it as a variable? Because we don't know the value of it, right? So we need to we can find it only based on the requirement given to us. Correct? So if I say x is a variable, I need to inform the person that I'm dealing with an expression where my variable is x. That is why if you see, p here stands for polynomial, and inside you have written that x, right? You're trying to tell the person that you're dealing with a variable x, a single variable x. So that in the place of x, you can substitute whatever real number you want, so that it will give you a perfect value. So that is what you have been doing. If I ask you what is p of minus half, let's make it even more simple. If I say what is p of minus 1, what will you do? So 2 into minus 1 square plus 3 into minus 1 plus 1. So it will be 2 minus 3 plus 1. Answer will be 0. So I randomly substituted and we got a 0. The final value is coming out to be 0. Right, now you have a grip of what is a polynomial. 1 by 2 will work. So it's a quadratic equation. If you factorize, you're going to get the answer, right? So what did we basically find? I substituted a number, and that number, when it substituted the place of variables, it gave me an output of 0. So what does that number represent for this polynomial? You call it as 0 of the polynomial. So what is 0? Any real number that you substitute in the place of variable, which gives you the output as 0, right? So in this chapter, what do you mainly deal with? You first try to understand the degree of a polynomial. Then you will try to understand what kind of a polynomial it is. And the third part is how to find zeros of a polynomial. And the last part is we are concerned about how the zeros are related with respect to each coefficient present in the polynomial. Right? This is how the chapter is divided. Am I right? So when I talk about degree of a polynomial, what will you say? And if you observe one more, thing, right? If I write p of x, can I write the question like this? P of x is equal to 2x plus 3y plus 1. Can I call this as a polynomial? Generally, when you represent, you can call it as a polynomial only when you try to represent how many variables you are going to represent. Did you do that? Which one? The HCF and then. It is an algebraic expression.
So I wanted to say that f of minus y will make it up.
That's sure. So x square plus y square into x square minus y square. But I didn't teach you the division of polynomial. You guys are comfortable with division of polynomials. And then it's the same thing. So how did you get this? F of minus y. Trial and error. Okay. You first have to equate this. Sorry. You first have to equate this to 0. Then you will get x is equal to y. So y is also a factor minus y square. You have for you to find it. So how did you get this idea of minus y?
First, I split the first one into
that I understood.
Factors.
So this can never
then
be
I
equal
was
to
taking
0.
each factor with this.
Okay. Did they give x and y as positive numbers? No, nothing, right? So x square plus y square generally cannot be a 0, because x square plus y square is always a positive value. So x plus y, if you equate it to 0, x can be equal to minus y, and x minus y, if you equate it to 0, x can be equal to y. Then you check f of minus y and f of plus y. Correct? Correct.
Instead, you're not supposed to put 2 Do I put it as is equal to f of x?
No, you can do it, but if it is a polynomial of two variables, we don't have it. When you go to advanced standard, you will do it.
This is a polynomial of two variables.
You can say polynomial of two. It's generally a function actually. Call it as a function because when you talk about a polynomial, right, even in talk in terms of functions, we generally use only one variable. So what is the general expression of a polynomial? I'll come to that point, okay? So can I call this as a polynomial? Why? Because whenever a question is given, right, that x plays a very important role. That's what. So P stands for polynomial. In the bracket, you're writing a variable, right? That variable will decide how many variables are supposed to be on the right hand side. Okay. And if you take the general expression of a polynomial, how is it written? What is the general expression of a polynomial? So you write it as a naught x power n plus a1 x power. You can write down 1 degree less a2 x power n minus 2 plus so on till the last number. You can write it as a constant. You know this, right? You don't know this. Tell me, right? You know or not? You don't know? Okay, then please make a note of this. So I thought you already learned it. So are you clear with what is a polynomial in the first place? A polynomial is basically an expression. Okay? An expression in terms of one variable where you have the variable with different degrees multiplied with constants. Correct? Can I say it like that? So I'm trying to give my own definition. I'm not following the book and all other things. So once you get a grip of what is a polynomial, then you can try to write the general expression of a polynomial. P of x is equal to a naught, where a naught is some constant multiplied with a variable raised to the power n, and that is added to another constant multiplied with a variable x power n minus 1. So if you keep on writing like this, I'll write this expression again. Listen. So P of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on till an. So what does this an, last an stand for? It is a constant basically, correct? So when you write it, this is called as general expression of a polynomial that is a quadratic, right? That's the specific condition of, I wanted to tell you something, of degree. What should I write it? You know what is the degree, right? Highest power of the variable present. So of degree n, right? So based on the degree, right? If you take the polynomial of degree 1, you call it as a linear polynomial. If you take the polynomial's degree to be 2, you call it as a quadratic polynomial. So what is the difference between a quadratic polynomial and quadratic equation? Equation will be equal to 0, whereas polynomial will be an expression, right? Similarly, if you take a third degree, if you take a polynomial of degree 3, what do you call it as? You call it as a cubic polynomial, right? So in a similar way, I can call this as the general expression of a polynomial of degree n, where that n can vary from any value, right? So we need to understand what are all the expressions which are not polynomial also. So when you're trying to write, so let's try to read the statement. So if I write 4x plus 2, I can call it as a polynomial of variable x. So if I write 2x square minus 3y plus 4, then I can call it as a polynomial in variable y of degree 2. Similarly, if I have 5x cube, this one, 5x cube minus 4x square plus x minus root 2, then what can I call that as? That is also a polynomial of degree 3, right? Whereas, if you look at the expressions like 1 by x minus 1, can I call it as a polynomial? No, you cannot. Similarly, you have root x plus 2. Can I call it as a polynomial? Because what is the power of x that is being written there? It is a rational number. It is x power half. Okay, plus 2. Similarly, 1 by x square plus 2x plus 3, I cannot call it as a polynomial. Okay. So then, if I give you a question like this, for example, P of x is equal to x square minus 3x plus 2. Sorry, minus 4. If I ask you what is P of 2, what will you do? P of x is equal to x square minus 3x minus 4. If I ask you what is P of 2, what will you do? Substitute that, right? So you call it as 4 minus. So answer is going to be minus 6, correct? Okay. Now I'll just give you another perspective of this. So you're writing a function, a polynomial function. I'll call it as a polynomial itself. Okay. You're writing this polynomial in terms of this variable, right? Generally, that variable is called as independent variable. What is it called as? It's called as independent variable because generally in this place, x, right, we can think of substituting any real number we want because it's a variable. By substituting that, what will we keep exploring? By plugging in different values of x, we'll be exploring what outcome is going to come out. That outcome, so this P of x, the outcome which you are going to get is called as a dependent value, and the value x is called as independent value. This is where the concept of coordinate geometry works. So when you take the coordinate, right, when you take this as x and y, okay, it is not always necessary that y-axis should only be y. For example, in this case, I can take x and P of x. Are you able to understand what I'm trying to say? Y is P of x. You have learned coordinate geometry, right? I'm slightly going into a higher perspective, try to understand. Okay, why I'm just trying to tell you why we are learning this. Okay, what is the application of functions in the first place? Okay, so what did I call x as? Technically, you call it as independent variable, and P of x can be called as a dependent variable. That P of x is what I'm considering it on the y-axis. That is why going forward, right, whenever you're drawing a graph, in linear equations in two variables, did you ever try to find out the solution for two equations graphically? What is the meaning of it in the first place? So you have something like this, right? 2x plus 3y is equal to 1. For example, I want to draw the graph of this. I'll tell you how you are actually borrowing the idea of polynomials. What do you generally do? You'll first rearrange the equation, you'll directly start solving it. You'll first rearrange, no? 3y is equal to 1 minus 2x. So y is equal to 1 minus 2x by 3. Can I call this 1 minus 2x by 3 as polynomial? Did you ever think of that? So it is a polynomial and it is a linear polynomial. That is why linear equation in two variables. Right? So instead of y, can I call this as P of x? Correct? So what you generally do, you take a table like this, you'll take x and you'll write y. No, instead of y, we can write it as P of x also. That is what you're actually doing in this chapter. You're getting prepared for the next chapter. Are you able to understand what I'm trying to say? So generally, you learn any function. Whenever a variable comes, right, most of the things in mathematics is mainly done to observe something graphically. Because more than math, right, these coordinate geometry and all other parts we use in physics a lot. Especially when you talk about motion chapter. Did you learn about the different types of graphs that you have? You learned about displacement time graph. You learned about velocity time graph. Then you learned about acceleration time graph. So if you observe in all the three, what is common? Time is common. Where do you generally take the time on the? You always take it on exact because time is independent. Time will not wait for you and me. It will run on its own. But who's controlling? Like time is controlling us. So we are dependent. Speed is dependent on time. That is why you see time is always taken on x-axis. There will be no graph in this world where time is taken on y-axis. Okay. Now, how your physics will give you a perspective of polynomials. See, you know this equation v is equal to u plus at. Right? When you draw a VT graph, You draw something like this. Correct? Velocity is taken on y-axis and time is taken on x-axis. If the initial velocity is not zero, you remember that the graph will be like this. Initial velocity is not zero and the object is accelerating. Correct? Now, this is in terms of physics. But as a mathematics student, can you say that this is also a linear polynomial? Because in math, what are we used to? We are always used to x, but start coming out of it. Here, what is the variable? T. You know what is a matured way of writing it? You write it as V in the bracket, you put a T is equal to U plus AT. So is V, I call it as P of X. Can I write it as U plus AX? Both are same only. So second expression, what I wrote is mathematics. The first expression, what you learned is physics, but both represent what? A polynomial. Are you able to understand why you're learning? So you would have thought that what is there in substituting the zero, finding out zeros and all those things, right? Actually, it has an application, right? So you're mainly learning all these things for graphical representations in science. Clear? So it's not only with physics. When you go to your 12th standard, you have learned chemical reactions and equations, right? But were you ever bothered of thinking, were you ever bothered thinking of the fact that how fast the reaction is happening or how slow a reaction is happening? Did you ever ask that question? You know what? Yes, it's all, so that is by someone is inducing the process. If two reactants are added, how fast they react and give us a product, right? So how fast or how slow can I call it as rate, right? So there is actually a branch of physics, branch of chemistry which deals with the speed of reaction, which we call it as chemical kinetics. So at that point also, you'll be using mathematical equations. So mostly you're learning this polynomials or you're learning linear equations in two variables, right? They are not confined to that particular chapter. They are confined to use them in different parts of science. I want you to have this point in mind. Is it clear? Are you getting a different perspective of what you have already learned? For example, if I take another equation of motion, let's try to relate it to physics itself. If I take this equation, S is equal to ut plus half at square. Can I call this as a polynomial? Observe it clearly and tell me. So S of, very good. S of t is equal to, so you're not confused between S of t and u into t, right? If you put something in bracket, it is not multiplication. You're saying that is the variable I'm using on the right hand side. So S of t is equal to ut plus half at square. If I want to write the same thing in mathematics, I'll call it as a value p of x is equal to ux plus half into ax square. So what is this actually? It is actually a quadratic polynomial, right? So in your quadratic equations, did you find out the zeros by drawing graphs? Did you do it? Yes or no? No. Did you see these kind of graphs? Did you see these? So what are these called as? This is called as a parabola. Okay. So a second degree polynomial, when you plot it on a graph sheet, represents parabola. So about the linear polynomial, you have learned in your linear equations in two variables. So linear polynomial on a graph sheet will represent straight line. Second degree equation in a second degree polynomial on a graph sheet will always represent a parabola. So when I say a parabola, here I have an upward parabola. You would have seen graphs like this also. Are you able to understand? The same thing is applicable in physics also. When you draw the graph for S is equal to ut plus half at square, you will draw half parabola. This is T, this is S. You any idea why we didn't draw it on the left hand side? Because time we don't generally take it as negative. So negative means we talk about the past. So you always do things in physics after starting the stopwatch. So are you able to connect it? So this is the overall perspective. In this, we are learning a small part, which we will see. Okay. So this is the meaning, guys. So now you got a perspective of what is independent and dependent variables, why we are studying in those things in the first place, right? So here, if I look at this graph, what do I call this point alpha and beta as? In terms of quadratic equations, you call them as roots. In terms of quadratic equation, you call them as roots, whereas in terms of polynomial, you will call them as zeros. That's it. That is the only difference. So zeros of a polynomial and roots of a quadratic equation, they represent the same thing. They have the same meaning but different names. Okay. So connecting all the dots, let's try to find out how to write the zeros in terms of the coefficients that are given. See, suppose I have a linear equation in one variable. Okay, if I have, let's say, a linear equation in one variable, which I'll call it as ax plus b. Okay, so how do I write the zero of the polynomial of this polynomial in terms of a and b? So first thing what we are supposed to do is write ax plus b is equal to 0, right? Then what we'll do, we'll find out x value. X is equal to minus b divided by a. So it is negative of constant divided by coefficient of x, correct? Similarly, if I have ax square plus bx plus c, this is a quadratic polynomial, right? I want to write the zeros of this quadratic polynomial in terms of its coefficients. How do I do that? But how did you get it? That is more important. You need to know why you are writing. Simply proof is there, but you know, yeah. You want to say? You want me to repeat the? Yeah, right. So for ax plus b is a linear polynomial. So I asked you, for linear polynomial, will you be able to write the zeros in terms of the coefficient? So I wrote it no. So what do I mean by zero? I need to substitute a specific number in the place of x in that polynomial so that the overall expression will lead to 0. That is why you call it as a zero of a polynomial, right? So ax plus b is equal to 0 means if I rearrange the equation, ax is equal to minus b, x will be minus b by a. So that is what I told. Similarly, if I have a second degree polynomial or a quadratic polynomial and I want to write the zeros of this polynomial, how many zeros will a quadratic polynomial have? The degree of the equation will decide the number of zeros. The number of zeros might be the same, or they can be different also, right? So I want the zeros of this polynomial to be written in terms of coefficient of a and b. Sorry, the coefficients of the polynomial. Coefficients used in the polynomial. How do I write it? It's simple, ma. Simple. Okay. Let's not break our head. Let's think of a logic. Okay. If I need a second degree equation, if I need the square of something, what do I need to multiply? I need to multiply two numbers. I'll get the, see, if I take a number and multiply with another number, I'll get the square of it. Correct? So if I need to increase the power of something, I need to multiply a term with power 1 into another term with power 1. Accepted? So let me say this is equal to x minus alpha into x minus beta. Got it? Okay. This is x minus alpha into x minus. Can I take it like that? Right. What is this called as? This is, so if I say, listen to this very carefully, guys. If I say alpha and beta are zeros, then I'm trying to say x is equal to alpha and x is equal to beta are zeros. Okay, or to be more specific, I'll call it as x1 and x2. So because there are, so since I used alpha beta here, I didn't use x1 and x2 here. Okay, x is equal to alpha and x is equal to beta are called zeros, and x minus alpha is equal to 0 and x minus beta is equal to 0. X minus alpha and x minus beta are called factors. This is a language used in mathematics. So x is equal to alpha and x is equal to beta are, alpha and beta are roots, whereas x minus alpha and x minus beta are called as factors. So when you multiply the factors x minus alpha into x minus beta, am I not supposed to get a multiple? Factors multiplied will give me multiples. Multiples broken down will give me factors. So multiples broken down is what you're actually doing in quadratic equations under the name called as factorization. Factorization, name you're finding the factors. Are you able to understand? So this x minus alpha into x minus beta, if I multiply these two factors, what will the expansion give me? 2 for cubic. X square minus of alpha plus beta into x plus alpha beta. Correct, Ada? Is there anyone having a doubt? Don't just nod the head for my satisfaction. You should understand. Is it clear? Is everyone clear with what I wrote? Okay. So when this is the scenario, then can I say ax square plus bx plus c is the same as x square minus of alpha plus beta plus alpha beta? Correct? Right. So one change I need to do here is I have the coefficient of x square here as 1. Here I have the coefficient of x square as a. So if I take that a outside, then I'll have x square plus b by a into x plus c by a will be equal to x square minus of alpha plus beta into x plus alpha beta. Correct? I took that a out. Now I'll do a comparative study on both the sides. Okay. So one change is what I will do is first step itself. See, I'll write the steps again. I want you all to copy it. You didn't learn the proof. You directly learned it as this is the equation. Follow it. Correct? Okay. Now see it. Is it tough? Is the proof tough? Let me complete it. Then I'll ask this question. So a into x square plus b by a into x plus c by a. Is this step clear? See, it is like you have learned about completing the squares in quadratic equations. No, that is deleted. What is there to delete? I don't know. Okay. So for that, you always, the first step, you make the coefficient of x square as 1. Okay, that is the first step in writing something as a perfect square. Okay. See, for example, I have 2x square plus 4x plus 4. I want this to be written as a perfect square. The first thing that I will do is I'll take the 2 outside. I'll make the coefficient of x as 1, x square as 1 plus 2x plus 2. Okay, small correction. This is 2. So this will be 1. Okay, so 2 into what is this going to give you? It is x plus 1 the whole square. You're able to understand what I'm saying? This is what, see, I've taken a very, very basic example, but this is called as completing the square. Means if a given quadratic equation, you have a quadratic equation and you want to write it in the form of a complete square, then you follow this method. What is the first step? Make the coefficient of x square as 1. So I need to take the coefficient of x square outside and divide the whole expression with that value. That is what I did on the other side. Does that make sense? You have some confusion. I'm able to see it in your face. Please ask what is your doubt. So this is the polynomial. Okay. If this polynomial is given to you, okay. For example, I asked you that 2x square plus 3x plus 1. I'm giving you a random polynomial. I'm saying alpha and beta are the zeros of this polynomial. Then tell me what is alpha plus beta. Will you be able to tell me? Minus 3 by, that is 2. Alpha into beta is c by a. That is 1 by 2. You know this, right? I'm trying to explain why you're doing this in the first place. Who told you that this is how you need to write? I will say alpha plus beta, write it as plus 3 by 2, put a minus half here. You'll still blindly accept and follow it. Correct? Because I told you. But you should ask me, right? How did you get it? So what I'm saying is we are trying to find out the answer for it. Okay. So I took that a outside. A into x square plus b by a. So you understood? So I need to divide the whole expression with that a. So when I divide a with a, it is 1 b by a plus c by a. Okay. I am saying this is equal to, this is a multiple. This is a number. So if I need to get a second degree equation or a second degree polynomial, I need to multiply two linear polynomials. What do I need to multiply? Two linear polynomials. If I multiply, I'll get a second degree polynomial. So this I will write it as a into x minus alpha into x minus beta, where x minus alpha is one of the factors and x minus beta is another factor. Or what is alpha and beta alone? Alpha and beta are zeros. X minus alpha and x minus beta are factors. Okay. So when I do this, I am doing individually. See, left hand side I'm not disturbing. Left hand side is a into x square plus b by a into x plus c by a. This a, I'm saying it is a into some. I am saying it should be a into product of two factors, two linear factors. Okay, this I will write it as, observe only the right hand side, a into, when I multiply x minus alpha and x minus beta, what am I going to get? X square minus of alpha plus beta into x plus alpha beta, correct? Correct. So this a and this a I can cancel it. Now I will compare both sides. So I have x square here. Alpha plus b. So left hand side the coefficient of x is plus b by a. Right hand side the coefficient of x is minus alpha plus beta. From here I can say alpha plus beta is minus b by a. Purida. So when I do the comparative study again, c by a is alpha beta, which implies alpha beta is equal to c by a. Are you able to understand? So there is a shortcut to write this also. Every time you need not sit and do, but I'm trying to explain you the way. You got for 30. 4 for 2 for 4. Others, you can copy this. This one. This is there. That book has proofs. So you know this last year itself. But now it makes sense, right? Now. Delta. You know how to write delta? S and close it like this. Like you have caps and small, Greek also has it. Delta is capital, this is the triangle is capital, this is small. Correct? Then, so shall we go and shall we go to the next step? Shall we try for a cubic polynomial? Sure. Write it. Yeah. C by A. So we'll go to the next proof. That is ax cube plus bx square plus cx plus d. Okay. So what should be the first step? Tell me. Same procedure. I should take out a. Correct. D by a. Okay. Let this expression be equal to a into, you guys tell me, how many factors am I supposed to introduce? Correct. Now, we'll concentrate only on the right hand side. A into x minus alpha into x minus beta into x minus gamma. What will you get? It is slightly a lengthy process only, but we'll multiply and see. When you multiply these two, what will you get? X square minus of alpha plus beta into x plus alpha beta into x minus gamma, correct? So how many terms are there? 3 terms, 2 terms. So let's see. A into x cube minus gamma x square minus alpha plus beta into x square plus alpha plus beta into gamma. Just I multiply both of them.
This is for CBSE.
All PDF. Okay. X cube. Simple, right? X square into x cube. X square into gamma, gamma x square. Minus alpha plus beta into x, alpha plus beta into x square. Minus alpha plus beta into x into gamma, alpha plus beta into x into gamma. Is that clear? You tell me the next term. This alpha beta x minus. Okay, now collect all the common terms. See, x cube, you don't have any other x cube, right? Plus, I'll write x square. Okay, x square into, what do I have? Minus alpha plus beta minus gamma. That's it, no? So I will write it as minus x square only. Alpha plus beta plus gamma. Correct? Plus alpha plus beta. So this will become, collect all the x terms. Alpha gamma, x into alpha gamma plus beta gamma plus alpha beta. Correct? So x into alpha gamma plus beta gamma plus alpha beta. Correct? Minus alpha beta gamma. Any doubt in this? Right? This should be equal to whom? A into x cube plus b by a x square plus c by a x plus d by a. Now what are we supposed to do next step? Now what will you do in the next step? Comparing on comparing on both sides, I have B by A is equal to minus of alpha plus beta plus gamma. C by A is equal to alpha beta plus beta gamma plus gamma alpha. Correct? Plus, sorry, not plus. D by A is equal to minus alpha beta gamma. Now you got the answer. So alpha plus beta plus gamma is minus B by A. You already know this, right? Beta gamma plus gamma alpha is equal to C by A. Sorry, no plus here. It's a gamma. And alpha beta gamma is equal to minus D by A. That's clear? So like this, you can do for any polynomial, any degree polynomial you can do that. Okay. So I'll just tell you the method of directly writing. I'll tell you the shortcut, then you can copy it. Okay. See, for example, I have ax cube plus bx square plus cx plus d. If this is a polynomial, generally you will have first everything will start with sum of roots, and the last it will end with product of roots. In between, you will have combination. Okay. So you start with sum of roots. Okay. You write product of roots. In between, what will you have? So here you are adding one value, right? Then you will have product of two roots taken together at a time. So alpha beta plus beta gamma plus gamma alpha. Am I clear? Okay. So put a plus minus on top of it with a pencil till you get used to it. So when you're starting with, so for everything, the common term in the denominator is A. Done? So forget the first term. So alpha plus beta plus gamma start from here. You'll write a B, but what is B having? Minus. Alpha beta plus beta gamma plus gamma alpha. This will be there. What is C having? A plus. Alpha beta gamma. It is D. What is D having? Are you able to understand? Like this, for example, I want to see how much you're thinking. Okay. So what should you start with? How many roots will be there? 4. Alpha plus beta plus gamma plus delta. Next one will be. So always it is like this. Sum of each term. Then alpha beta plus beta gamma plus gamma delta plus delta alpha. Then three terms take it together. Alpha beta gamma plus beta gamma delta plus gamma delta alpha. Yes, and a circle like this. So you would have learned about this, right? There are two deltas. Like how you have this delta and this delta. Both are different, uppercase and the lowercase. I don't remember which one is upper and which one is lower, but yeah.
I know that capital is the capital alpha even in
You don't have, I don't think alpha is a capital and small.
then
So you have for certain terms, omega has, see, for example, in current electricity, you learn this omega and you learn about this omega. So both are called omegas. Okay, anyways, we'll come back to this. So are you able to understand alpha plus beta plus gamma plus delta, 2. So what will be the last thing? Product of everything. Okay, so it starts with sum of each, sum of 2 taken at a time, 3 taken at a time, 4. Right? So alpha plus beta plus gamma plus delta. So plus minus plus minus plus. So alpha plus beta plus gamma plus delta. What will you have? So what is common in the denominator? A and A. How many of you are bus students? Nobody, right? So no problem. Okay. Alpha plus beta plus gamma plus delta. You tell me. Minus B by A. Alpha beta gamma. Huh? You understood the logic, right? Then that's. So this is how the pattern keeps going. Okay. So this is what you need to write. So I'm not sure till where you have copied. You didn't even start. Do one thing. What is the time? 5:27. No, I don't know how to share. So I'll do one thing. If I share it with you, this document where I've written, can you share it with others? Okay. So whosoever has messaged me, I'll send it. from the student support number. Okay, I'll do it now. It's so that you can copy. If you message from some other number, let me know the name. That's okay. Or else I'll have to go and see your description. I didn't say, I don't know. So but fortunately it was there. Narayan is here, so I could respond. And yesterday you told me about the drive, no, so I could relate it. You didn't send the name, you sent the screenshot. No, yeah. Yeah,